Okay, welcome back. Now, the last video ended pretty abruptly. I thought I had a few more seconds, but apparently not. So, I did a little bit of research. Like I said, I used to program in Unity JavaScript. However, I haven't recently, so I forgot a lot. Now, the reason I was adding stuff to the end of the list in JavaScript was because I didn't know how to add stuff to this beginning. So, if you look in C#, I have my add to set.insert 0 n, right? So that means I'm inserting the transform n in the 0th position in the set. So basically, I'm putting it in the first position in the set. So I'm adding it, and I'm making it the first. So what was the first is now the second. What was the second is now the third, so on and so forth. In JavaScript, I had it a little different. In my add to set function, it was set.add to add, and then it was in set.length -1. So what this did is it put the transform to add in the last spot. I mean, this could work, and it does work, but I think it's so much easier to understand if you put it in the first spot. So just to keep everything the same between my two scripts, C# and JavaScript, I'm using the unshift keyword. So unshift is basically the same thing as insert to the front. You can go ahead and look at the Unity3D documentation. Array.unshift adds one or more elements to the beginning of the array and returns the new length of the array. We don't need to know the new length right now, but we do want to add to the beginning of the array. And something interesting is that there is no insert. So there's no insert in JavaScript's arrays. So that's kind of weird, and that's what threw me off. But using unshift will work. Anyway, let's keep going. So last time we made all these variables. Now what I'm going to talk about is the core of the script. Now, this is going to get a little complicated. Let me uncomment these. Okay, this is what we're going to be talking about. It's a double do loop. Or it's a double do well loop, actually. And this might get really hard to follow, so let me explain what's happening here. Inside this first loop, it's a do while next x is less than 0, next z is less than 0, or next x is less than 0, or next z is less than 0, or next x is greater than grid array dot get length 0, and actually instead of grid array, this could be grid size dot x, which just makes so much more sense. That's what we have the grid size thing there for. Okay, so what is it saying? Well, remember how we had these directions over here in the inspector? This array or list of directions. What we're going to be doing is, I'll go ahead and start. Now, we're starting at this 0, 0 corner, right? And from here, we're going to go up, right, down, or left. So we're going to move in one of these directions and look at the script, or the cell there. So if you look up, we'd be looking at this one. If you look to the right from here, it'd be on this one. But if we look down, there's nothing here. So this first do loop is going to try and get us into a valid cell. So let's go up to this top corner. Let's say we started here, okay? And the first direction we look is up. Now this isn't necessarily true. We're going to be randomizing the direction we look first, but let's just say that's what happens. So we look north. So we have random direction, which would be north. So we pick a random one, and let's say we get north. So next x is going to be our previous x, which was over here, 0, 9. So 0. So we'd have 0, or next x equals 0, which is what we had before, plus 0 actually. And next z would be 9 plus 1, because we're going up. So 0 plus 0 is 0, right? And that's a legitimate x value. We can have an x value of 0. However, 9 plus 1 is 10. And if we look here, there's no cell named 0, 10. Right? It goes up to 0, 9. So that's too far out. That's not a valid cell. So what we then do is, we'll talk about this later also. What we do is have random seed equals random seed plus 1 mod 4. So we increment the random seed. So if it was 1, now it's 2. And what this mod 4 does is it keeps it always between 0 and 3. So if we have 3 and we added 1, then with the mod 4, well, what's this? Then with the mod 4, we would have 0 again. So no matter how many times we increment this, this will always stay between 0 and 3. If you want to look up on this a little bit, I recommend you just go to YouTube and look at, well, not YouTube, Google and look at modulus. Really, it's a math function. It has to do with remainders. So go ahead and look this up. Yeah, modulus operator. Something like C++. In JavaScript and C#, it's notated with the percent sign. This is taking a long time to load. Just gonna pause it until it loads. Okay, it's loaded. Right here. This so yeah, go ahead and look that up on your own time. And if you need me to explain it, go ahead and ask. But what we're gonna do is we're gonna be using that, and we're gonna keep going through this loop until we get a cell that's valid. So if x is less than 0, or next x is less than 0, we don't have any cells that are named -1 or anything. So if it's less than 0, it's not valid. Same thing with the z. If next x is greater than grid size.x, or greater or equal to, so if grid size x is 10, so we have 10 wide. If we get 10 as next x, we know that's not valid. And same with next z. So we keep doing this in the loop, and then it's in a larger loop, which I'll talk about in the next part. Okay, so here's what it looks like in JavaScript, and then in C#. It looks like this. Okay, thanks for watching, and these scripts are available by request. See ya.